All right, so you've been hearing a lot about DeepSeek lately and want to understand what they're actually doing tech-wise.
Yeah, DeepSeek's story is fascinating.
So let's dive in.
They're a spin-off from a Chinese hedge fund.
Really?
And they've basically said, we believe in AI so much, we're going to pour over $500 million of our own money into it.
Wow, that's a serious commitment.
Yeah.
They're not messing around. I mean, they've only got a team of 150 people.
Right.
But they're going to toe-to-toe with the biggest tech giants out there.
Mm-hmm.
And in some cases, even winning.
Right.
There's got to be a secret sauce here, right?
Absolutely. One of the first things that jumps out is their sheer computing power.
Okay.
DeepSeek has amassed a stockpile of around 50,000 Hopper GPUs, including the really hard-to-get H800s and H100s.
Hold on. 50,000 GPUs.
Yeah.
How does that even compare to other players in the field?
Very few AI labs have that kind of firepower centralized in one location.
Wow.
It's really only comparable to what Elon Musk is doing with X.AI. We're talking about a server investment of around $1.6 billion, plus another billion in operating costs.
That's mind-boggling. No wonder they're making waves. But there's also been all this talk about how much it costs them to train their V3 model, something like $6 million, right?
Right, but that $6 million figure is a bit misleading. It only accounts for the cost of running the GPUs during the initial training phase.
So it's just a fraction of the actual cost.
Exactly. It's like saying building a house only costs the price of the bricks. You're forgetting about the design, the labor, the land, all those other expenses.
Right.
In DeepSeek's case, that means all the research and development that went into creating the model's architecture, plus the cost of maintaining that massive GPU infrastructure.
So it's not just about the raw computing power. It's about how you use it.
Yeah.
Speaking of V3, it's been getting a lot of attention for its performance, especially compared to GPT-4o. But GPT-4o came out almost a year before V3. Does that really make it a fair comparison?
That's a great point. AI is moving at such a rapid pace that what was cutting edge a year ago might be considered standard today. It's natural for newer models to achieve comparable or even better performance with less compute as the underlying algorithms improve. It's a testament to how fast this field is evolving.
So DeepSeek's V3 is impressive, but it's not necessarily revolutionary in the grand scheme of things.
Yeah.
But what about their R1 model? That's the one focused on reasoning, which seems to be the next big frontier in AI, right?
Exactly. R1 is DeepSeek's answer to OpenAI's O series of models.
Okay.
And it's really fascinating to see how they're approaching this. What's remarkable is that they've managed to achieve results comparable to OpenAI's O1 model, which was announced just a few months prior.
Okay, so they're hot on OpenAI's heels in the reasoning game. But how do they manage to catch up so quickly?
Well, the shift towards reasoning has opened up new avenues for faster development.
Okay.
Instead of relying solely on massive pre-training data sets, DeepSeek has incorporated synthetic data and reinforcement learning into R1's development. This allows for much faster iteration and significant gains with less compute power.
So it's like they found a shortcut, a more efficient way to get to the same destination.
Right.
Clever. But hold on, there's something that's been bugging me. You mentioned that the R1 paper doesn't specify how much compute power they actually used.
Yeah.
Why would they be so secretive about that?
That's a great observation, and it's probably deliberate. DeepSeek might be downplaying their actual GPU usage to maintain their image of efficiency and cost-effectiveness.
Right.
But let's be realistic. Training a model like R1, especially with all the synthetic data generation and reinforcement learning involved, takes a lot of computing power.
So they're playing their cards close to their chest, which makes you wonder if they're really as efficient as they claim to be. And even if R1 is impressive, it's not like it's blowing other reasoning models out of the water.
Right.
We've got OpenAI's O3, which is supposedly even more advanced. So where does that leave DeepSeek?
You're right. O3 is the current gold standard. But DeepSeek's R1 does raise some interesting questions. For example, Google released Gemini Flash 2.0. Thinking, also a reasoning model earlier this year, and it's reportedly cheaper than R1. So what's DeepSeek's pricing strategy?
Right.
Are they willing to undercut the competition?
Interesting.
Are they prioritizing market share over immediate profit?
That's a fascinating angle. It's like they're playing a long game betting on the future of AI. Okay, but let's get down to the nuts and bolts here. What are the specific technical innovations that have allowed DeepSeek to achieve these results?
Now, this is where it gets really exciting. DeepSeek has made some key innovations that have allowed them to achieve these impressive results. For example, their V3 model uses a technique called multi-token prediction, or MTP.
Multi-token prediction. I'm intrigued. But that sounds a little complicated.
It can be, but think of it this way. Instead of predicting just the next word in a sentence, MTP tries to predict several words at once during the training process.
So it's like looking ahead, trying to anticipate what's coming next.
Exactly.
Does that really make a difference?
It does. This approach helps to improve the model's overall performance. And the best part is it doesn't add any extra computational burden when you're actually using the model because it's discarded during inference.
Oh, so it's like a booster rocket that falls away once the model is launched. Very clever. What else?
Another innovation is their use of a mixture of experts model, or MOE.
MOE. Okay, you're going to have to break this one down for me.
Imagine a team of specialized experts, each with their own area of knowledge. A MOE model is similar to that. It's made up of smaller specialized models, or experts, that work together to handle different aspects of a task.
So it's a divide and conquer strategy where each expert focuses on what they do best.
Exactly.
But how do they know which expert to call on for a given task?
That's where DeepSeek's gating network comes in. This network efficiently routes tokens, the building blocks of language, to the right expert, ensuring a smooth and balanced workflow without impacting performance.
So it's like they've got this team of experts all working together and a traffic cop directing the flow of information to make sure everything runs smoothly.
Okay, so we've talked about MTP and MOE, both of which are used in V3. But what about R1? You mentioned that it leverages reinforcement learning, right?
Yes. R1 builds on the solid foundation of V3 and adds a layer of reinforcement learning, or RL. This is where they really focus on shaping the model's reasoning capabilities. During RL, they emphasize things like formatting helpfulness and harmlessness. Basically, they're teaching the model not only to give coherent responses, but also to be useful and safe.
So it's like taking a really bright student and showing them how to apply their knowledge in a practical and ethical way.
Yeah.
I like it. Earlier, you also mentioned synthetic data. Why is that so important for R1?
Synthetic data is artificially generated data that mimics real-world data. It's extremely valuable for training models like R1 because it exposes them to a much wider range of scenarios and examples than you could get from real-world data alone. It's like giving the model a crash course in every possible situation, so it can learn to generalize and reason more effectively. That makes sense. But wait, wasn't there something about R1's training data being controversial?
There's been some speculation that DeepSeek might have used data generated by OpenAI's models as part of their training process for R1. This has raised some eyebrows because it brings up questions about data ownership and whether DeepSeek is playing by the rules.
It sounds a little like they're borrowing someone else's notes to study for a test.
Yeah.
Okay, let's move on. You mentioned something called multi-head latent attention, or MLA. That sounds pretty complex. What is that all about?
MLA is one of DeepSeek's most significant contributions, and it's a game changer when it comes to reducing the cost of running their models, especially for inference. Essentially, MLA allows DeepSeek to drastically reduce the amount of KV cache required for each query.
Hold on, KV cache. I'm not sure I remember what that is.
Think of KV cache as the model's short-term memory. It's a memory mechanism used in transformer models, like the ones DeepSeek uses, that helps the model remember the context of a conversation, which is essential for generating coherent and relevant responses.
Okay, so the KV cache is like the model's working memory. How does MLA help with that?
By minimizing the KV cache requirement, MLA reduces the amount of hardware needed to run the model, which directly translates to lower costs. This is a major breakthrough because traditionally the size of the KV cache grows with the complexity of the model and the length of the conversation.
So MLA is like compressing the model's memory without losing any of its knowledge. That's amazing. But wouldn't that give DeepSeek a huge competitive advantage? I mean, if they can offer their models at a much lower cost than their competitors, they could really shake things up.
It certainly could. There's speculation that DeepSeek might be offering inference at cost or even at a loss to gain market share and undercut competitors like Google.
Wow.
It's a risky move, but it could pay off big time in the long run.
So they're playing the long game. They're not afraid to take risks, and they're definitely shaking things up. What does all of this mean for the future of AI?
Well, DeepSeek's meteoric rise and their impressive technical achievements have sent a shockwave through the AI community. They've shown that it's possible to challenge the dominance of the big tech companies, even with a smaller team and a different approach.
It's a classic David versus Goliath story.
Yeah.
But for the AI age, it's exciting and a little bit unnerving at the same time.
I agree, and it raises all sorts of questions. For example, what does DeepSeek's success achieved outside the traditional Silicon Valley ecosystem mean for the future of AI development and competition? Will we see more companies like them emerging from unexpected places?
It's like a whole new world of possibilities is opening up, and the pace of innovation is only getting faster. What other groundbreaking advancements are just around the corner?
That's the beauty of this field. It's constantly evolving with new discoveries and breakthroughs happening all the time. DeepSeek is a prime example of that.
Well, folks, it looks like we've reached the end of our deep dive into DeepSeek. We've uncovered their remarkable journey, their technical innovations, and the potential impact they're having on the AI landscape. It's clear that DeepSeek is a company to watch, and their story is just beginning.
And remember, this is a field that's constantly evolving. What seems groundbreaking today might be commonplace tomorrow. So keep exploring, keep learning, and keep asking those big questions.
Thanks for joining us on this deep dive into DeepSeek. Until next time, stay curious.